What I was tasked with and what I want to do is I just want to sort of walk through the idea of resilience and how it applies to transportation. The field of resilience is an interesting field because the people who sort of play in this sandbox really are of two types. On one type, we've got people who are sort of physicists and mechanical engineers and electrical engineers who write really sophisticated mathematical models and computer simulations. On the other hand, we've got people who are more policy-oriented who spend a lot of time thinking about the richness of the real world. So what I'm going to do is I'm going to talk in a little bit more constrained way than the previous two talks, just to try and give us, in some sense, a basis, a foundation through which we can think about what resilience means and how we sort of create resilient systems. So a brief outline of what I'm going to do. I'm going to first talk about resilience writ large. This is sort of, in some ways, when I teach resilience to my undergraduates, this is sort of a version that I would teach to them. Then I'll talk about, just really briefly, about how to apply this to the topic of transportation. And I have to be totally honest here. Over the last 2-3 weeks I've been trying to put this talk together, it's been really a challenge. And the reason why is I realize after reading a lot of Sue's stuff and Tom's stuff and other things that in some sense the problem is too large. And we'll talk about why that problem is so large. And then I'll lead to then a final point on collective wisdom, how diversity can help us possibly overcome those problems. Okay, so first, resilience writ large. The concept of resilience, and Tom hinted at this, originally came from physics, and it had to do with the ability to absorb energy and then pull it back. So a really good spring is resilient in the sense that most of the energy that gets put down, right, gets pushed back up. A spring would not be resilient if you pushed it down and it just stayed squashed, right? There's many definitions, new definitions, and some people talk about maintenance of functionality. And there's other people who are more optimistic who use the word flourish instead, so I'm going to stick with that. But the idea is that it's the ability to flourish in the face of adaptation, randomness, invasion, disruption, trauma, and environmental stress. Now, what's important, and this is, I think, a key point. I'm trained as an economist and as a sort of someone from a business school, and we speak a lot about stability. And 15, 20 years ago, you'd read very little about resilience. You'd read a lot about stability. You'd read a lot about the stability of the financial system, stability of political systems, those sorts of things. What stability means is that if you push a ball up, right at the bottom of this bowl, that it returns to the same state. So a system is stable if you push the little ball, it goes back. It's unstable if you push it and it goes someplace else. Resilience means something different, right? Resilience means the ability to continue to flourish. But it doesn't mean that you necessarily flourish in the same way. You may have to find some other way, right, in order to continue to do what you want to do. So a classic example of a resilient species or entity, or even a firm, let's say, would be the sandhill crane, right? So sandhill cranes have been around for, some people claim, 10 million years. We have solid evidence that they've been around 2.5 million years. And Tom and I were talking, they actually saw the Lions have a winning season, the sandhill cranes have. Now, what is it about the sandhill crane that's allowed them to live for 2.5 million years and other species not to live for 2.5 million years? So these are the sort of things that people, and the same is true if you look at companies, right? What allows companies and organizations to live a long time? And one of the things we'll get to, which is really interesting, is efficiency is not the answer. So if you go to Wikipedia and you look up longest living organizations, what you're going to find are universities, bars, churches, and liquor companies, right? Those aren't necessarily the most efficient organizations, right? But the thing is, for some reason, they've been resilient. And if you look at the sandhill crane, we have some that walk across our yard every morning. These do not look like the most efficient species you've ever seen, right? So it's one of the things we want to make sense of. Psychologists. There's a huge field in psychology related to the notion of resilience. And what this is this is your ability to sort of, again, withstand trauma. The ability to sort of have really lousy things or even really good things happen in your life and to continue to flourish. So, for example, a lot of lottery winners find their lives fall apart, right, because they're not resilient to good events. And a lot of people, if the death of a parent or the loss of a child, right, can send them to a spiral where they need psychotherapy. So when they talk about psychological resilience, again, what they mean is the ability of your brain to withstand some sort of shock. Political scientists, people who study institutions, talk about resilient government structure. So the Articles of Confederation, which we started out with, right, lasted 6 years because the structure that was put in place wasn't resilient in the sense that it didn't have enough coverage, it didn't have enough redundancy, and it didn't have enough diversity. And so because of that, the Articles of Confederation didn't work, and we had to replace them with a more robust design. When we think about something like a transportation system, though, and here's one, I think the natural thing to do is, because we tend to map these things this way, and when I was reading a lot of this literature on this, is to think of them in terms of networks. And so not surprisingly, one would imagine, most companies and most government organizations think a lot about network robustness, but it's done in the context of information systems, right? So when you think about things like local area networks or the internet, there's a lot of work on how do you construct robust and resilient networks, right? And again, to these same sort of things, these traumas, that sort of stuff. And it's easy, I think, to fall into the trap of thinking about the transportation system like one of these sorts of networks. But one of the things we heard from the previous two talks is it may be more appropriate to think of it more like an ecosystem, because we've got these patterns of behavior matter so much. We've got these purposive actors in our system that respond and adapt to what's going on. So let me give a quick, brief aside on this notion of resilience versus efficiency, right? Again, I was trained as an economist, and so we do all these sort of models with, price and quantity, and we get supply equals demand, and we talk about this being the efficient outcome. And if you talk to people on Wall Street in 2006 and 2007, they would have said, look, all these derivatives we're creating, all this bundling of loans, that's just making the system more efficient. Well, let's just do some really simple math. 2007 was the best year Wall Street has ever had. Here's the profits for Citigroup, Bank of America, AIG, JP Morgan, and Wells Fargo. And those are some pretty substantial profits. The $21 billion, I think, is the 7th most profits any company's ever had in the history of the world. So that's pretty good, right? Let's look at the TARP funds they got the very next year. 50 billion, 45 billion, 40 million, 25 billion, 25 billion, right? So this squeezing the onion to get a little more profits, to be a little more efficient, had massive costs, right, in terms of outlay. So this is one way to think about this efficiency resilience trade-off, right? That if we focus too much on efficiency, we're not going to be resilient. And this is why when you look up the organizations that have lasted a long time, they tend not to be efficient things. They tend to be messy, diverse, modular things like universities. Okay, so when we say resilience, if you look at the theoretical literature, the things that the mathematicians, the physicists, the engineers have been playing with, they really have 7 sort of core things that they think about in terms of resilience to what? Okay, one is knockout, and I'll go through these in some detail. Another one is invasion. Another is innovation. Fourth is environmental stress. A fifth is trends. A sixth is trauma. And the last one is internal dynamics. So let me walk through exactly what I mean. So when they say knockout, they literally mean knockout. So this is the Northridge earthquake, and if you ever wondered why you should have a camper, here's the reason why, right? People in the camper, I guess they're just playing euchre in the back, and everything's fine. This same sort of experiment is done with, local area networks, with the internet, with financial systems, with genes, right? So people who do, who work in genetics, do these experiments where they go do knockout experiments on particular genes and ask, is the offspring still viable? So when you look about sort of the resilience of the genetic code, one of the things that there's a lot of work done, Andreas Wagner at New Mexico is one of the leaders, and at Vienna, they do these exact sort of knockout experiments. You just knock out one bridge and next, does the system still work? Now, an interesting thing about this, the Northridge earthquake knocked out, it almost looked like strategic bombing, right? We had this knockout of all these different highways, and yet the LA economy, for the most part, went on without a blip because there was so much adaptability. Okay, a second thing, and this is a big one that people don't think about, because we often think of these sort of events or these external things, is invasion. So this is a tree in which an emerald ash borer, which came into Detroit in a crate from China, came and they wiped out now all the ash trees in Michigan. Most of us are probably familiar with this, and this is the girdling of the ash tree that happens, right? You can think of similar things with the zebra mussels that have come into the lakes of Michigan. So one of the things you want to ask about in terms of a system is the system robust or resilient to invasion? A particular type of invasion that happens a lot in these systems where you've got purposive actors is innovation, right? So when a new product comes in, sometimes a new product can just sort of add to the ecosystem and make things better. Sometimes a new product can come in and can wipe out the entire ecosystem. Now, it's interesting, even though the ash trees all got wiped out, the forest still survived, right? And so a lot of times with innovation, you get something that economists like to call creative destruction, right, where you constantly have new ideas coming in, but you maintain the flourishing of the functionality of the entire system. Now, a lot of this stuff, a lot of this sort of deep mathematical work on resilience started out in engineering, and some of it looked at stress. So this is sort of the classic model of tectonic plates, hitting each other in models of earthquake. And what you get is stress along these plates. And the question is, how much stress can these plates withstand before you get this sort of massive disruption? And so, again, there's lots of mathematics behind this, but one of the questions is, can a system withstand this stress without falling apart? An example of a kind of stress, and I'll separate this out in our case, is a trend, right? And so this is a graph that Tom likes to put up all the time. If you look at this, it's sort of hard to make an argument that we're not seeing increases in global temperature. And so what we want to ask is,